Recently, I was having a conversation with a friend of mine, and we were talking about the earth being in motion. And they asked me a question that is a very common question. I see a lot of people ask, I see it in chat boxes, comment sections all the time. It's a really good question. And the question that they asked was basically, if the earth is in constant motion, why is it that the impact rate is different if you drop a bowling ball, let's say, from the top of a building versus from the top of a house? And sometimes when you're trying to give someone an answer or explain it, it can be a little difficult without having the visuals to go along with it. So I thought I would put this little visual aid together for anybody else who might have had this question, and maybe this will help my friend understand what I was trying to say. So let's get into it. So if this is the ground, right? And the ground is moving upwards at a constant rate, we're going to give the rate 100 miles per hour. That's typically the number I use because I don't know the exact speed, but this is an easy number that anybody can visualize in their mind. Now, right here, we've got a house. Okay, I am standing on this house and I'm holding a bowling ball. Now, here we have a building. Well, that didn't quite turn out right there, did it? Let's try to fix that. Okay, so here, did it again. Sorry, guys. I'll get it together in a second. Here we have a building, and I am standing on top of the building holding a bowling ball. Now, while I am holding the bowling balls, keep in mind that the bowling balls, me, the buildings I'm standing on, and the ground are all attached. We're all moving as one. We're all moving upwards at 100 miles per hour. Now, when I release the bowling balls, okay, they do not, contrary to what other people say, they do not freeze in midair. They do not hover in midair. This is a misrepresentation of anything I have ever said. They will continue moving in their upward trajectory, but they begin to lose their momentum or their speed. Okay, so they start to slow down. Now, why they start to slow down is a different topic for another day, but they begin to lose their speed. So notice the difference in the distance between the ground and the bowling ball here and here. In the building scenario, you have a much greater distance, which means that that bowling ball is going to have much more time to slow down before the ground comes up and impacts it. Where at the house scenario, you don't have very much distance between the bowling ball and the ground. So there's not very much time for that bowling ball to slow down before the ground comes up and impacts it. Now, let's say in the scenario of the house, because there's not much time for the bowling ball to slow down from its constant 100 miles per hour, we're going to say by the time the ground comes up and impacts it, it's dropped down to, let's say 90, let's say 90 miles per hour. And in the scenario of the bowling ball in the building, by the time the ground comes up and impacts it, it's had much more time to slow down. So let's say by the time the ground reaches it, it's slowed all the way down to 10 miles per hour. Okay. That means that in this scenario with the house, when the ground impacts that bowling ball, the ground is only going to impact it at a 10 mile per hour impact rate. Where in the scenario of the bowling ball in the building, the ground is going to impact it at a 90 mile per hour impact rate. So you see the difference? That is why you have to factor in the distance, meaning the time that the object has to slow down before the ground comes up to meet it, because that is going to be what the impact rate depends on. Now, obviously, as I said, there's other factors in why the object slows down and what will determine, the speed it slows down to and stuff like that. But the point is that the object will slow down, which means that the ground is going to be moving that much faster than the object is. They're all moving in the same direction. Now, when the ground impacts the bowling ball in the scenario of the house, it's barely just going to bump that bowling ball. Where with the building, it's really going to impact it, because 90 miles an hour impact rate is pretty big. So I hope that makes this a little bit more clear. Hopefully that answers the question. Y'all have a good one, and I'll catch you next time.